All right, welcome back, everybody. Today's installment is on an introduction to hypothesis testing. Now, this is a brand new topic with potentially a lot of things you've never seen before. So today's installment is going to be a very conceptual day. I'm going to introduce a lot of the different things that you're going to see in hypothesis testing and discuss them in a little bit more detail. That way, in my next installment, when we're dealing with examples, we can simply execute. All right, so the goals for today, we're going to talk about the null and alternative hypotheses. We'll discuss what is the claim, level of significance. There are actually 3 different types of tests that we can wind up doing: finding a critical value and types of errors from hypothesis testing. All right, so here's the situation. USA Today publishes that the mean SAT score is 910. So if I'm going to write this out symbolically, here I'll just switch over to a pen. I'll say mu equals 910. The superintendent of your school wonders if your district mean, which would be X bar because your district would be one sample, of 960 is higher than the national mean. Now, at first reaction, you might say, of course it is. 960 is greater than 910. Done and done. But is it different enough is the question. And this is what very often is meant by statistically significant. All right. So for the most part, I'm going to talk about the different steps in what we call the traditional method of testing. There are a couple of other methods. One is called the p-value method, and one is called the confidence interval method. I will take up the p-value method in the next installment. All right, but we're going to focus here on the traditional. All right, so first let's discuss what is a hypothesis. All right. That's a terrible S. I can do better than that. All right. A hypothesis, you might have heard this before, is an educated guess and we'll relate it to statistics. So it's an educated guess about a population parameter. All right, now the population parameters that we'll focus on in the next couple of sections are going to be mu or p. And if we remember from our confidence intervals, P would be the population proportion. All right, so hypothesis testing is seeing if that educated guess is valid based on the evidence in the problem. So I'll write that out. That's if that educated guess is valid based on the evidence. That's very important. All the things we're talking about are all going to be based on the evidence that's given. All right, so that will be something that we will discuss more as we get into the examples. All right, in any example, we'll be working with 2 potential hypotheses. All right, the first is the null hypothesis. which is denoted as h sub 0. All right, and this, right, this is defined as the null hypothesis states that there is no difference between the parameter and the specific value. Very often, you can identify the null hypothesis because it'll be the one with the equal sign attached to it. And we'll talk more about that in a little bit. The second hypothesis we're going to have is called the alternative hypothesis. Which is denoted as H1. Some of the newer books have HA. I like HO and H1. So that's what we're going to use. And this states that there is a difference between the value and the parameter. And the parameter. All right, so we're going to look at a few examples and explore how to state HO and H1. Okay, so a researcher knows the average pulse rate for the population is 82. A researcher is interested if a specific medication will have side effects, particularly with regard to the pulse rate. Will the pulse rate increase, decrease, or remain unchanged? All right, so we need to start with our null hypothesis. And our null hypothesis is HO. And our null hypothesis, again, is just that our population parameter is true, which is that mu would equal 82 as our pulse rate. All right, H1 is the alternative, and since the researcher is exploring whether the medication could increase the pulse or decrease the pulse rate, we could say our alternative, our opposite hypothesis, would be that it does not equal 82. And we're not going to take the problem any further. Again, I just want to talk about the null and alternative hypothesis. All right, good. Let's take a look at the next example. A chemist invests an additive to increase the life of a car battery. If the mean life of the car battery is 36 months, HO and H1 are. All right, so let's take a look. So HO, let's see. Here I'm going to start with H1. H1 meaning the alternative. So the chemist invents an additive to increase the life of a car battery. So he wants to test to see if the life of the car battery lasts longer. So he wants to test to see if mu is going to be greater than 36 to whatever specifications that he had. Now remember, our null hypothesis is going to basically be the opposite of that. So it's going to be that mu not just equals, but less than or equal to 36. Then I have all my bases covered. All right? And again, we're just stopping there to kind of sort out our null and alternative hypotheses. All right, let's try one more example. All right, so my third example. A contractor wishes to lower heating bills by using a special type of insulation in houses. If the average monthly bills are $78, HO and H1 are. Again, we have no other information except for the potential to know what our null and alternative hypotheses are. So the null would be, okay, so the alternative, again, that the average would go down. So if the average is going to go down, I'll say the average is less than 78. And my null would be the average would be greater than or equal to 78. Once again, so I have all my bases covered. All right. So now we've talked about the null and alternative hypotheses, but we also notice in these there is kind of written in a claim. For example, the contractor is using the special insulation to lower heating bills. So that would be kind of like his claim. Let's take a look at a few other statements and see if we can identify what the claim is. All right, so here's a couple of examples. And again, I'm just piecing out statements to talk about what the claim is. So, first example, most people get their jobs through networking. Well, if most people get their jobs through networking, you could say the alternative, which is what you're going to test. Now, I didn't talk about anything about average, so this would be a proportion that P would be greater. If I said most, I probably would classify that as bigger than 50% or 0.5. So I'm going to label this as the claim. It is important to label your claim because when you're going through the process of either rejecting or not rejecting your null hypothesis, it's important to know what your claim is so you can make a proper conclusion. All right, so the second statement says the average payload of trucks on a certain highway is 18,000 pounds. Now, once again, I see the word average in there. So I'm going to make this my null hypothesis. And I'm going to say that the average equals 18,000 pounds. Now, again, I use the null for this one because it was equals. And I'm also going to label the null my claim. I wanted to try to do one with an alternative and one with a null because your claim could be either one. It doesn't have to be one or the other, but we're always testing the null hypothesis. So if you want to test your claim, then we need to test your null hypothesis. All right, so that's what we're always testing. All right, and again, we're either going to reject the null hypothesis or not reject the null hypothesis based on the evidence given. A lot of people talk about, make an analogy to a courtroom. When you're in a courtroom and you go through this case, the judge either says you are guilty or not guilty. He never says innocent because it's always based on the evidence presented. So, for example, OJ was not guilty based on the evidence. He could have done it, but based on the evidence that was given, they could not make him guilty. So you're either rejecting the null or not rejecting the null. You are never accepting. All right? All right, so let's try one more. The mean of fluid in a can is at least 12 ounces. All right, now this could relate to soda. It could relate to water. Could relate to beer. Could relate to a variety of different things. And very often, companies will test how much fluid is in a can to make sure that they're not shortchanging their customers. So it says the mean fluid in a can is at least 12 ounces. So if it's at least 12 ounces, right, I'm going to make my HO mu. At least means the lowest it could be would be 12, but it could be greater. And since we have an equals as a part of it, I want to make that my null hypothesis. My H1 is the opposite, which means that mu is less than 12 ounces. And that would be bad, because if I bought Diet Coke and I got less than 12 ounces in my can, I would not like it one bit, and we'll label HO as our claim. All right. So now we got to talk about level of significance. All right. And when we talk about level of significance, and our level of significance is denoted by alpha. Now, you may remember alpha from our confidence intervals. It is the same type of thing. So the three basic alphas that we have would be 0.10, 0.05, and 0.01. All right. Now, these aren't the only alphas that we're going to work with, but these are the typical ones. And they're going to help us find our border between the rejection region and the do not reject region. All right. Now, we are going to wind up with z-scores for each of these, but we're not going to just simply have three typical z-scores, because it depends what type of test we're doing. There are three types, and I'm going to talk about them briefly right now. The first is, right, the three. The first is a left-tailed test. All right. And in our left-tailed test, right, let's say our alpha equaled 0.01. 0.01 would be the area here. All right. And this, all right, and this would be the rejection region. And over here would be the do not reject region. And that would be based on the z-score that we figure out. All right. So how would you find the value right there? You would look up 0.01 in your chart, right? That's area to the left would be 0.01. And then you would get the corresponding z-score, which should be negative 2.33. All right, so the second type of test we have is a right-tailed test. And I'm going to draw that out for you. And it's very similar to the left-tailed test, except, and I'm going to again use 0.01 as alpha. That's my rejection region. All right, but now in order to find my value, I want to look for my area to the left. My area to the left is 0.99. And when you go to your Z table and you look up 0.99 for your area and get the corresponding Z-score, it should be 2.33. The last test we're going to talk about is called a two-tailed test. Now this two-tailed test, I'll draw it out for you. Make that better. Is going to have z-scores equidistant apart, and my rejection region is going to be, if alpha is 0.01, is going to be alpha divided by 2, which would be 0.005 and 0.005. And in the middle, I would have 0.99. Now, in order to find your z values, right, I'm going to look for area to the left, right? So my area would be, that I'm going to look up, is 0.995. And when I look up 0.995, I get 2.58. And if the other one is equidistant away, it's negative 2.58. If you want to confirm that, the area you should look up is 0.005, and that value should come either way. Now those z values over here, right, that create the border between the rejection and the do not reject region, I'm going to refer to them as critical values. All right. So in order to find the critical values, we kind of discussed it here, but I wanted you to focus on left and right tail. So let's do a little bit more. All right. So let's say we had a left-tailed test. And alpha was 0.1. So we'll use a different alpha. All right. So I want to draw it out. I always like drawing these things out. I think drawing these out help. I think it's a real good visual to make sure that you're going in the right direction. All right. And making sure that you have your negatives and positives perfect. All right. So if I'm on a left-tailed test, that means my critical value should be negative. So I have 0.1 in my rejection region. And I want to go to the z table. And I'm going to pause this in a minute. I'm going to say look up 0.1, which would be my area to the left. And then let me know what your critical value is. All right, hopefully you paused it and looked up that critical value. And I found the critical value to be 1.28, but it's got to be negative because we are in the left tail. All right, let's try another one. The next one we're going to try is going to be a two-tailed test. And alpha equals 0.02. All right, let's draw this out. And there's my rejection region. Now, this alpha is split evenly between the two tails. So in here, I have 0.01 for my area. Here I got 0.01 for my area. So now I need to look on the table for my area to the left. Now that area I'm looking up is going to be 0.99, right? Because I have 0.98 left in the middle. All right, so it's 0.98 plus 0.01, 0.99. And I want to get both values. So why don't you take a moment, pause the video, look up the values, and come back and we'll talk about it. All right, hopefully you paused the video and looked up those values. Now the first value you should have gotten was 2.33. Now again, we can use symmetry to say negative 2.33, but I do hope that you took the time to look up 0.01 as the area in your table and found negative 2.33 to be that value. All right, now of course we did a left-tailed and a two-tailed test. So I would be remiss if we didn't make our final example a right-tailed test. With alpha equaling 0.005. All right, so let's draw out my right tail. Again, I still feel that drawing it out is always best. 0.005. So the area I'm going to look up is going to be 0.995 because that's the area to the left. And when I look up that area to the left, I get a value of 2.58. Why don't you confirm that as well? All right, so one more thing I quickly want to discuss. I just want to put it out there that while we are doing hypothesis testing and while statistics is wonderful and very often we can either reject or not reject the null hypothesis, there are actually 4 possible outcomes we can have. To a hypothesis test. So let's see. We can reject or not reject. Right? All right. So if we now here's the thing. Now this chart basically works like this. If I reject the null, but the null hypothesis is true, then I have an error, right? I've rejected the null hypothesis based on the evidence, but the null hypothesis is true. This is called a type 1 error. All right. Now, if I reject the null, but the null hypothesis is false, then I made a correct decision. Right? Now, again, we're always going on the evidence. It doesn't mean you did the problem wrong if you reject. All right? Now, if we do not reject the null and the null hypothesis is true, we are correct. If we do not reject the null hypothesis and the null hypothesis is false, then we have a type 2 error. All right. So now how do we represent our type 1 and type 2 errors? Well, the level of significance also known as alpha, is the maximum probability of a type 1 error. So we denote the type 1 error with an alpha. All right. Now, how do we denote the type 2 error? Right. The probability of a type 2 error is symbolized with a beta, Greek letter beta. And I will talk a little bit more about type 1 and type 2 errors in future sections. All right. Now, very often I don't require a certain set of procedures to happen. But I do think the procedures that are outlined for hypothesis testing are really good to follow. And I think they're really good to write out because, number one, I think you'll get more problems right. And getting more problems right is always the goal, right? You always want to get the question correct. However, if you happen to make an error in the question, I do believe the more that you write out, the more partial credit you will get. So, and I think it's always good to get a lot of partial credit. So here, to sum up, I'm just going to kind of sum up the steps that we're going to use to solve hypothesis testing questions. All right, so the first is we're going to state the hypotheses. And identify the claim. All right, and that's always written into the problem. I can't necessarily tell you that there are specific words to look for, but as you read more problems and more problems and more problems, hopefully some of those you will find some of those helpful hints and some of those words that will help you identify potentially what the claim is or how to write out the null and alternative hypotheses. All right, the second would be find your critical values. The third is going to be compute the test value. And the test value, again, is going to be you're going to get the numbers from the problem. I will talk more about that in the next installment. Fourth, we're going to make a decision to reject or not reject. And it's always the null. It's either we reject the null or we do not reject the null. And lastly, I'm going to summarize the results. Meaning, write a very quick sentence as to what you found. Either there's enough evidence to reject the null hypothesis and continue, or there is not enough evidence to reject. And then you would complete it with the context of the problem. I do believe tying things back to the context of the problem is important. All right. So again, a very conceptual day. You might be a little worried that things don't feel like they're tied together. I do think that if you are feeling good about this and the follow-up, that in my next installment, it will tie together quite nicely because we'll jump right into a couple of examples. All right, guys, thank you for listening. I'll see you next time.